thank you guys for joining. Really great turnout and a lot of familiar faces, which is a little bit scary and good at the same time. So, like was said, I'm gonna concentrate mainly on the EVA engine that Qualcomm provides. Many of you may not know that there is this hardware engine inside of Snapdragon, because we haven't actually done a very good job of publicizing it, but we're gonna be doing this more and more. So this is actually a hardware block that sits inside of Snapdragon, kind of between the ISP, the camera ISP, and the hexagon tensor accelerator and the CPU. And it's a hardware core which has fixed function hardware to accelerate specific computer vision functions. And they kind of fall into a number of categories, like motion estimation, depth processing, geometric correction, feature extraction. A previous version of the block had face detection and face landmark detection, but that's been deprecated because we're now doing that in the NPU. And then very recently, we've added support directly for indirect time of flight image sensors. So all of these areas actually have been in the block for a while. We're now on version 4 of our block. Last year I was here, I talked about version 3. And we've made improvements in actually every single one of these areas aside from the face detection area, which I'll go through. So just a reminder for everyone, the EVA architecture, again, it's a fixed function hardware block, and it can be controlled either from the CPU or the HTA, the hexagon tensor accelerator. So mainly the benefit of this block is to offload these functions, and I'll talk about the functions block by block in a moment, so that you don't burn power or cycles in the CPU, GPU, DSP, et cetera. So it provides power savings, it provides performance enhancements over doing some of these functions in software, and so a lot of our customers really find this core quite attractive to use to offload their CV functionality.